Now that we've gotten the potentiometer, the NeoPixel light array, and the switch working with our Arduino, let's get the last peripheral working. And that would be the piezoelectric speaker. So if you notice the way I have this wired up, it's got a connector with 2 pins right next to each other on it. And so where could we plug this into the board and have it function correctly? If we go and take a look at the schematic and we look at the I/O connectors, there are no grounds immediately next to an I/O pin. So right here we have a ground pin, but it's next to SCK and AREF, which are not generic I/Os. So what can we do to get this to plug into somewhere on this connector and function? And incidentally, it could also be a power pin and an I/O pin next to each other, which we also don't have. And the reason why piezo will work with either power or ground on one of the terminals is because all a piezo really cares about is seeing a voltage difference across the wires that are attached to it. Whereas on a speaker, if you actually apply a DC voltage, you could burn the speaker coil out. That's why this piezo is actually nice to work with, because it's very robust and a DC voltage will not destroy it. So let's go back to the editor and let's take a look at some of the examples. So if you go into the digital examples, there is this program here called Tone Melody. Let's take a look at that one. So we notice here that they want to put an 8 ohm speaker on digital pin 8. Well, ours is not an 8 ohm speaker, and we don't want to use pin 8 because it's very close to our switch right there, if you can see it. So let's just take a different pin. Let's select pins 2 and 3. And so 3 is a generic I/O, so what we'd really need to do to make that function is drive it out with a signal near ground. So let's go into setup, and let's say pin mode 2, so for pin 2, and then we're going to make it an output. And remember, before I made this a define, well, we'll just take the quick shortcut and put the actual value there instead of making a define. And then we'll do digital right pin 2, and we'll drive it low. Like that. So now pin 2 is going to sort of function like a ground pin. And then if we use pin 3 for the other side of the speaker, then we should be able to drive it. So if we look in their code, they said pin 8 right here is what you'd connect to the speaker. So we'll go find where they do that. So this tone function uses a pin number and then a frequency, which is this right here, and then a duration. So if we change this 8 to 3, and then down here, this no tone, also change that to 3. So now we're driving the signal on pin 3, and pin 2 is low. So let's plug the speaker into our board. First we'll unplug it. Unplug the board, that is, from the USB port. And we'll plug it in here. So if you can see, that's right there, pin 2 and 3 right there, 2 and 3. And this is our speaker, our piezoelectric speaker. And now let's plug the Arduino back into the USB port on the PC. So it's powered up. And let's try running the code. And there you can hear that it played a melody, which is what the code is set up to do. Let's take a look at the code a little bit and see how that works. So they've created this array of integers that have these names, note C4, G3. What that means is it's C, and it's the 4th octave, and then note G third octave and then play it again, and then you can see the pattern they're having here. And then the durations, this is in musical notation where this is a quarter note, eighth note, quarter, 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 quarter. And so the code down here basically just plays these two in parallel, this note for that length and then that note for this length, and goes on like that. Also note that all of this code is actually just in setup, and the loop doesn't actually have any code in it. And that's because they have this melody just play once and then stop. If you were to copy this melody down into the loop area, or actually move it to the loop area, then it would just play over and over again. So a couple more things worth mentioning here. First of all, these are not defines that are always available to Arduino. These are actually located in this include file, pitches.h. And the other thing I thought it'd be worthwhile is showing that if we do instead make this signal high, we can show that it still works. So let's try that. And you see that it sounds the same.